This is lesson 6.6 on dilations. It's the first lesson about transformations, and you should have a note-taking sheet available on Canvas that you can use to follow along, or a paper copy of it in class. So first, our definition that we're talking about today is dilation. A dilation is a type of transformation, which just means change, that changes the size but not the shape of a figure. So it'll result in a similar figure, same shape but a different size. A scale factor is something that you've already talked about in 7th grade math. You've dealt with scale factors, and it's just a number, a quantity, that describes how much a figure is enlarged or reduced. We multiply by the scale factor. Now, an image is the figure that results after a transformation. Before a transformation, it's called a pre-image. So after a transformation, it's just called an image. It uses a prime symbol, such as A prime. It looks like an apostrophe after the letter that has been transformed. Example 1, tell whether each transformation is a dilation, and then explain. So I'm going to start by noting these two figures. I'm going to go ahead and label the points. So this large one is figure A, B, C, D. And after the change, the dilation, it becomes A prime, B prime, C prime, D prime. And what I'm looking for is to see if the sides of these two figures are proportional. So I can compare the ratios of corresponding sides. So for example, I'm going to compare AB to A prime, B prime. So I've got AB and I've got A prime, B prime. And let me erase that. And so I'm going to take my original AB, and out of that original, I'm going to see what A prime, B prime is, and I'm just going to get a ratio of these two sides. So the segment A prime, B prime is 3 units wide. You can just count them. And the segment AB is 6 units wide. You can count that. And I'll reduce it, and it reduces down to 1/2. So it looks like it's reduced by a scale factor of 1/2. Then I could just go through and do the same with the other sides. So let's see, we have B prime, C prime, and BC. So I'm going to compare those. I'm going to take B prime, C prime, and BC. B prime, C prime was 3 units tall, and BC is 6 units tall. So I have a scale factor of 3/6, which reduces to 1/2. So since those two sides came out to the same scale factor, it's going to be a dilation. I could go through and check these others, but what kind of figures do I have here if all my sides are the same on this figure ABCD, and it's at 90-degree angles, and all the figures are the sides are the same on figure A prime, B prime, C prime, D prime, and they're all right angles? We're dealing with squares. They are the same shape, but different sizes, so this is going to be a dilation. I'm going to go ahead and finish that out. If we take C prime, D prime over CD, then we get 3/6, which is 1/2. If we take A prime, D prime over AD, we get 3/6, which is 1/2. So yes. And an explanation is that it's the same shape, they're both squares, but different sizes. And we know it's the same shape because they had the same ratios of side lengths. And it was very obvious that these were both squares because all the sides were the same and they were 90-degree angles. B part, we're going to compare the ratios of the side lengths again. This bottom triangle is triangle ABC, and this top triangle is triangle A prime, B prime, C prime. And at first glance, they appear to be about the same, but there is something that might be different about them. So let's just go ahead and start comparing some side lengths. Later on, I'm going to know how to find the diagonal side length, but I'm just going to go ahead and start with two I can count. I can count BC and B prime C prime very easily, so I'm going to start with those. I'm going to start with B prime C prime over BC. B prime C prime is 5 units wide, and BC is 6 units wide. So I get 5 over 6. If I change over here to A prime C prime and AC, I get A prime C prime is 4 units tall and AC is 4 units tall. So A prime C prime over AC is 4 over 4, which actually reduces to 1. These ratios are not the same. So I can already tell from these first two side lengths that no, it's not going to be a dilation. It's not proportional. It's not proportional, and if we were getting the same side lengths, it would show that it was proportional. And since it's not proportional, it's not the same shape. It's a different shape. Example 2. Dilate each figure by the given scale factor with the origin as the center of dilation. What are the vertices of the image? So we're going to start by noting what our pre-image is. We can also call this an original. And then we're going to use this little arrow symbol to show a transformation. Any transformation we do will set up this way to an image. And when I have an original or pre-image, I'm going to show my ordered pair. I always start by saying what I begin with, which is XY, the ordered pair. And what am I doing to that ordered pair? Well, I have a scale factor of 3. That means we're going to multiply by 3. So I'm going to take 3 and multiply it by x, and then I'm going to take 3 and multiply it by y. Or we could have just written that as 3x and 3y. So I'm going to take each ordered pair that I have here. Point A that I started with is 1, 1, and point B is 3, 1, and point C is 3, 3. And I just got them right here from this triangle, A, B, C. And then I'm going to multiply them each by 3 to get A prime, which is 3 times x, 3 times 1 is 3, 3 times y, 3 times 1 is 3. And I get B prime, 3 times x is 9, 3 times y is 3. And to get C prime, 3 times 3 is 9, and 3 times 3 is 9. So all I did was I multiplied each coordinate by 3, the scale factor, to get these vertices, A prime, B prime, and C prime. I could also graph this on my coordinate plane. I've got my A prime. I'm going to graph it in a different color. A prime is 3, 3. B prime is 9, 3. And C prime is 9, 9. Notice that it's using the origin as the center of dilation, so it's stretching out from the origin, and it's just multiplying all the sides out by 3. The side AB was 2 units wide, now it's 6 units wide. The side BC was 2 units tall, now it's 6 units tall. It just multiplied everything by 3. B part, we have a scale factor of 1/2. So we're going to take the pre-image and always go to the image, which means we're going from XY. And since it's a factor of 1/2, it just means that we're going to multiply 1/2 by x and then multiply 1/2 by y. So here are my ordered pairs. A is -6, -2. B is -2, -2. C is -2, -6, and D is -6, -6. And I just got them from these points on the coordinate plane, the corners of this figure that appears to be a square. And then I'm going to multiply each coordinate by 1/2. Now, I could go to a calculator and multiply by 1/2, but all I'm doing is saying what is half of that number. So for A prime, half of x, -6, is -3. Half of y, -2, is -1. For B prime, half of -2 is -1. Half of -2 is -1. For C prime, half of -2 is -1. Half of -6 is -3. And for D prime, half of -6 is -3, and half of -6 is -3. I've now got my ordered pairs. I could graph it. If I did, I would see that my square is half, the side lengths are half what they started out being. I could quickly do that. -3, -1, -1, -1, -1, -3, and -3, -3, and you see that it is half the side lengths, and it's closer to the origin. It's not stretched out as far. C part, we have a scale factor of 1.5, and we're given a triangle with the vertices 1, 2, 3, -4, and 1, -4. They're not labeled, so I'm going to go ahead and call them A, B, and C. And there's not a coordinate plane with this drawn. It's not necessary to graph them. A graph can help you, but we could use this rule and say we're going to begin with the pre-image x, y, and it's going to be multiplied by a scale factor of 1.5. So we're going to multiply 1.5 by x and multiply 1.5 by y. And so I'm going to take my ordered pairs, A, which is 1, 2, B, which is 3, -4, and C, which is 1, -4. And I'm going to multiply each coordinate by 1.5. So for A prime, 1.5 times 1 is 1.5. 1.5 times 2 is 3. For B prime, 1.5 times 3 is 4.5. 1.5 times -4 is -6. And for C prime, 1.5 times 1 is 1.5. And 1.5 times -4 is -6. And so I've gotten each of the coordinates of the image by just multiplying each coordinate by 1.5.